I'm going to use this study that looks at social connectiveness, self-esteem, and depression symptoms among college athletes and non-athletes to try to explain to you some important vocabulary words, specifically the difference between a parameter versus a statistic, the difference between statistical significance versus practical significance, and also show you some really important notations. And notations are just mathematical symbols, abbreviations that you want to make sure you understand, that you can practice writing if you want to be successful in this class. So this study is published in the Journal of American College Health, which is a reputable site. So anytime you look at a study, you always want to check to make sure it comes from a reputable source. And the whole purpose of this study was to try to compare college athletes to non-athletes and see if there were any significant differences in the students' social connectiveness, self-esteem, and depression. And if there is any uh, interaction between these variables that can also predict depression. So the first thing that I want us to take a look at is down in the methods here. You can take a look at how, so this is their sampling method, how they collected their sample and how they got participants to participate in their study. So let's first off talk about what is the, let me get my pen here, what is the population and what is the sample? So remember that a population consists of all subjects of interest, and a sample is just a portion from that population. So in this particular problem, if we look at the method here, it says that participants in the study, so let me highlight it, were a volunteer sample of full undergraduate students at a small private liberal college, and the sample size was 27 participants, or 227 participants. So the sample here would be, I'll just write down here, undergrads at private college. Okay, so this is just a subset from the population. So the population then would consist of all undergraduate, and I should say here undergraduate students. Students meaning they're looking at athletes and non-athletes. And so the population would be all undergraduate students. And let's just say in the US. Okay, so that's our population. And then this is our sample. When you start collecting data that describes the population, we call this type of information a parameter. So again, a parameter is a characteristic or something that describes the population. Now, when you are collecting data that describes some characteristic about the sample, then we call it a statistic. Okay, so a statistic refers specifically, oops, let me use my highlighter here. A statistic refers specifically to your sample, and a parameter refers specifically to the population. So let's take a look at this article a little further here. And there's a whole bunch of statistics in this entire paragraph here, but I'll just pick out a few. So something interesting here is, the first thing here is that it tells us that N, let me choose a different color here, is 227. So let me talk about what N stands for. N is your sample size, and the notation we use for sample size in statistics is N. Now, if I could collect data from the population, right, which is all undergraduate students in the United States, then I would also be able to come up with a capital N, which is the population size. So the population size is an example of a parameter. Okay, so you've got a statistics for the sample and a parameter for the population. What else can we get from here? So another interesting piece of statistic is here we're told that in this study of 227 participants, 59.9% of them were female. Okay, so this is another example of a statistic, and we call this a p-hat. So p-hat, which in this example, 59.9%, is what we called a sample proportion. So a proportion is some part out of the whole. So if the whole is 227 students, 59% of those students are female. So that is an example of a sample proportion. And again, if I had, if I'm looking at the population also has a proportion of the population that are female. So we use the notation P, where P represents the population proportion, okay? And in this specific example, that proportion is the proportion that is female. Okay, all right. Some other interesting statistics in this article is that we're told that the average age, I'm going to go back to my highlighter. The average age of the participants was 20 years. Okay, so this is an example of a statistic. And we call this, since it's an average, we call this X bar, where X bar represents a mean. And again, you typically think of the mean as an average. Okay, so here the X bar here is 20 years, the average age. And again, if we were looking at the population, if we had all undergraduate students in the US, we would also be able to calculate a population mean, so the mean age for the population. And the notation that we use for it is this Greek letter mu. Okay, so mu, which represents the population mean. Okay. All right, if we keep reading here, it gives us some more information in the study. So another statistic, if we look down here, we're told that the average age is 20 years with an SD of 1.33 years. So SD is a type of statistic, and it actually stands for standard deviation, but the notation that we use is S. So sometimes you'll see SD, but typically we just use S, where S represents the sample standard deviation. So in this particular study, that sample standard deviation of 1.33 years, and you'll learn about this more in chapter 3, but I'll just explain really briefly here that if the mean age is 20 years with a standard deviation of 1.33 years, that means that in the study of 227 undergraduate students, their average age was 20, but their age varies from that mean age of 20 by about 1.33 years. So 1.33 is a relatively small standard deviation, which tells us that in this sample, most of the students, they were pretty close in age, more specifically, close to 20 years, give or take 1.33 years, okay? So again, if we were looking at the population and I have a population mean, I can also calculate a population standard deviation, and the notation that we use for that is the Greek letter sigma. So sigma represents the population standard deviation, okay? And this article doesn't have this statistic here, but if I take the standard deviation and square it, that gives me the variance. So variance is another type of statistic. It describes a characteristic from the sample. And if I was looking at the population, that parameter would be sigma squared, which represents the population variance. Okay, so again, these notations, N, P hat, X bar, S, S squared, these are the notations that represent a statistic which describes a characteristic about the sample. And on the left side here, capital N, P, the Greek letter mu, and the Greek letter sigma and sigma square. These are all types of parameters that describe a characteristic about the population.